All right, welcome everybody. Today we're going to work through together some of the problems on homework 44. This is just extra practice finding polynomial equations from given zeros. We already saw this in one of our lessons and we did have some homework problems on it, but because it was not on our most recent quiz, I thought you could use some additional practice. So again, there's 9 problems total. I'm going to work together with you for the first 7. So fill them in as I go through them with you and then go ahead and try the last 2 before you submit. So starting off nice and simple, just to make sure you understand the basic rules, if I give you a factor, make sure you could solve for the corresponding zero. And if I give you a root, find the corresponding factor. And again, something to point out here is that 0 and root, those mean the same thing. It means x equals. So you're going to see those used interchangeably. So over here on the left, given the factor, find the corresponding zero. So notice that each of those parentheses are equal to 0. So all you have to do is solve for x. So in the first one, you would add the 5, which means x would be 5. In the second one, you would subtract the 3, so x would equal -3. And then for the last one, you'd have to do 2 steps. You would have to first subtract the 4, then divide by 3, which would give you an answer of -4/3. So again, notice that your answer is always opposite in sign. And then for something where there's a coefficient other than 1, like the last one, you just have to do that additional step. Over here in number 2, you're being asked to do the opposite. So given the root, find the corresponding factor. So if +4 is a solution, then that means that x minus 4 would be a factor, and you have to set it equal to 0 because that's the only way that 4 would be the answer. If you had x equals +2, you would go ahead and say x plus 2, and again, that would be equal to 0. Then for x equals 5/2, if you use the same reasoning that you did for the previous ones, you would say that the factor was x minus 5/2. Now, here's the thing. We tend to not really leave our factors like that. We don't really like the fractions. So all you're going to do to make it not a fraction is you're going to multiply everything by 2. If you do that, you're going to get a 2x. Then these 2's are going to cancel, which will give you -5. And then on the right, anything times 0 will, of course, remain a 0. So you have to make sure you understand the basics of 1 and 2. How do you take a factor and find the root? How do you find the root and find the factor? Now, we're going to bump it up a little bit. So for number 3, write a polynomial function with the given zeros in standard form. Hopefully you remember that standard form, that just means you have to multiply everything out. The opposite of being in standard form is being in factored form, but factored form is what you're going to start with. So if you notice, you have 1, 2, 3 factors here, or 3 solutions. You then have to have 3 factors. You have to call your polynomial something. So we're going to call the polynomial y equals. Could be y equals, could be f of x equals. In order for 0 to be a solution, you would have to have just a lonely little x. In order for 1 to be a solution, you would have to have x minus 1. And in order for -1 to be a solution, you would have to have x plus 1. So again, this is what we call factored form. In order to now go ahead and actually make it into standard form, you just have to multiply those 3 things together. Hopefully you remember that if you're multiplying 3 things together, you can start with any 2 of them. The easiest 2 to start with, just so you're aware, would be to start with x minus 1 times x plus 1. Maybe you remember that that is, of course, the difference of squares. It doesn't matter which 2 you pick, but if I go ahead and pick the red and the black, I'm just going to get x squared minus 1. Then I have to distribute this x, which means my polynomial equation is going to be x cubed minus x. That is considered to be standard form. And again, because they ask you for the polynomial function, they're not actually asking you for a factor or a solution. You just want to leave it as y equals or f of x if you would prefer. Similar scenario here in number 4, except you're not going to have any difference of squares, which means you're just going to have a little bit of extra work to do. So again, call it either y equals or f of x equals. I'll leave that to you. In order for the -2 to have been a solution, you would have had to have an x plus 2. +4 can only be the result of x minus 4. And -3 could have only happened if there was an x plus 3. So now you have to, again, multiply any two, and there really are no good options here in terms of which two. So why don't we just go ahead and do the first two? So I'm going to do a FOIL. So that's going to be first, outers, inners, and last. Then I'm going to clean that up a bit. So that's going to give me x squared minus 2x minus 8. And then don't forget about that x plus 3. So remember, there's more than one way to multiply a trinomial times a binomial, but the box method was how we first learned it. So if you like the box method, you're going to go ahead and rewrite along the top here, x squared minus 2x minus 8. Then you're going to do x plus 3 along the left side, and you're just going to go ahead and fill in all those boxes. So x times x squared is x cubed minus 2x squared minus 8x, positive 3x squared minus 6x, and negative 24. As a hint, if you've done this correctly, you're always going to have like terms along the diagonal. And because you called this f of x, we're going to say f of x equals, put x cubed first, then combine the x squareds, there's positive 1 of them. Combine the x's, there's negative 14 of them, and then negative 24 will go ahead and finish you off. Again, this is what we call standard form, which basically just means that you've multiplied everything together. That is how you deal with all of your rational solutions. So now let's talk about how you would deal with an irrational solution. And remember, there is something to help you with that called the irrational conjugates theorem. The irrational conjugates theorem is very simple. It says if you are given a irrational root, so 2 plus root 5, if you are told that that is a zero of the polynomial, then you automatically know that 2 minus radical 5 has to be a 0. If you know 1 minus radical 2 is a 0, then you know 1 plus radical 2 is a 0. And basically all the irrational conjugates theorem says is that these guys have to come in pairs. It has to be the same front, it has to be the same back, but it's always going to be the opposite middle. So how do I then take that and write some equations? So write a polynomial function with the given zeros in standard form. And just to be clear, that 3 plus radical 2, that is 1 whole 0. So automatically, I know that 3 minus radical 2 has to also be a solution. Why? Because they always have to come in pairs. So this is a little bit trickier. So I'm going to call it, again, y equals or f of x equals, up to you. You're going to start off with x, then you're always going to do minus whatever the first root is. Then you're going to do another parentheses, another minus, and whatever the second 0 is. Then there is a shortcut. So the sooner you can understand the shortcut, the better you're going to be. And again, because of the fact that everything is open notes, you should be easy to refer to them. So you're going to take these two values and you're going to put them together as a quantity squared. Then you have this positive and this negative. You're going to rewrite that as a negative. And then whatever is in the back, you're going to write that as a quantity squared. That is a trick that will work 100% of the time if you're trying to take two irrational roots and turn it into a quadratic. So now all you have to do is the work. So the first one is a FOIL. You would have to do x times x, and then x times negative 3, x times negative 3 again, and then the last. The square root of 2 squared is just regular 2. And again, if you have any question how I got from the purple to the blue, that's a FOIL. And then for my final answer here, all you're going to do is combine like terms and put it in standard form. So x squared minus 6x plus 7, that'll do you for the polynomial equation. Just note here, this is only a quadratic because there were only two solutions. And as hard as it's going to get, the most you have to be able to do is number 7, which is where you have to be able to do it not just for 2 solutions, but also for 3 solutions. So again, notice the first thing I'm giving you here is just a regular old 1. So if I'm talking about a regular old 1, I automatically know that I need x minus 1. Then remember that this 5 minus radical 3 has to stay together. So what can I automatically know? It also has to be 5 plus radical 3. Has to come in pairs. So I'm going to leave this x minus 1 where it is for a second. I'll come back to this when I need it, but I'm going to leave that in the corner for now, and I'm just going to deal with my 2 irrational roots. So if I'm just going to deal with my 2 irrational roots, then I'm going to say x minus the first thing, which is 5 minus radical 3. Then I'm going to say x minus the second thing, which is 5 plus radical 3. Then I'm going to do my shortcut. So the shortcut says take the first 2 things and turn that into a quantity squared. Then 1 plus, 1 minus, I'm going to leave that as a negative. Positive times a negative. Then I'm going to do my radical 3 times my radical 3, and I'm going to write that as radical 3 squared. Do the FOIL. So first, outers, inners, last, and then the square root of 3 times the square root of 3 is just 3. So if I clean that up, that's x squared minus 10x plus 22. And then from here, I now have to bring back my x minus 1. So far, what I have here is f of x equals x minus 1 times x squared minus 10x plus 22. The final step in order to put that into standard form is to multiply it. Remember, you can multiply it lots of different ways. Perhaps you might consider doing the box. So if you're going to do the box, you're going to do x squared minus 10x plus 22 along the top. Just making sure I copied that right. Yep. And then x minus 1 along the bottom. Go ahead and fill everything in. So x to the third minus 10x squared plus 22x minus x squared, positive 10x, and negative 22. Again, if you've done this correctly, your like terms are always going to exist on the diagonal, and all you have to do to finish it up is go ahead and combine like terms. So x to the third minus 11x squared plus 32x and minus 22. So definitely focusing on quality over quantity. All you have to do now to finish up are the remaining 2 problems, one of which is only using irrationals for a quadratic, and then one of which uses irrationals for a cubic. If you're able to do these last 2 problems, and if you review 1 through 7, hopefully you will understand this concept. So thanks very much for tuning in, guys. Go ahead and finish the rest of the homework. Don't forget to submit it, and have a great day.